Hi guys, we're gonna do a quick, wow, let's unmute here. Hopefully you can hear. Yes. Okay. We're gonna run through this super quick. And this is the binomial theorem. It is a quick way of doing something like a plus b to the sixth power or to the 23rd power or to whatever power. Um, and it really is going to reduce down to some of the stuff that we learned about yesterday. And this array of numbers is called Pascal's triangle. Pascal's triangle. I've got a neat little toy in the garage that I will pull out for our next meeting, which demonstrates some of the principles here. Hang on, my daughter is yelling at me. Bear! Okay. If I take a plus b to the 0th power, well, anything to the 0th power is just 1. Notice that 1 there. A plus b to the 1st power, anything to the 1st power is self. Notice I have a 1a and a 1b, and there is a 1 and a 1. A plus b squared is a 1a squared plus 2ab plus 1b squared. So over here I would have a 1. Well, I see a 1 and a 1. I'll add them together and get a 2, and then a 1. Following that pattern, this next row should be a 1. 1 plus 2 is 3. 2 plus 1 is still 3. And 1 plus nothing is going to be 1. And notice that I have a 1, 3, 3, 1 over there, and so on and so forth. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And let's finish it off with a 1, 6, 15, 20, 15, 6, and 1. There are innumerable patterns that you could conceivably find in this. You can look them up online. You can discover some for yourself. I'm much more interested in what it applies to. So imagine, for example, that I had, instead of A and B, I had a W and R. That might seem a little bit arbitrary, but and I were to square it, I'd end up with a W squared plus 2RW plus R squared, with a 1 there and an implied 1 there. For those of you who have taken some biology, you might recognize what I'm doing. If I had a white rose and a red rose, for every 4, 1 plus 2 plus 1, offspring, I'd expect one of them to be white, 2 of them to be red, white, red, 2 of them to be pink, and 1 of them to be red. So just an interesting place where it shows up. Given row 6 now, write row 7, we know how to do that. You add, I get 21, you add, I get 35, 21, 35, 21, 7, and 1. And so if I expanded x plus y to the 7th, I would have 1 x to the 7th, technically y to the 0th, plus 7 x to the 6th, technically y to the 1st, usually don't write that first, plus 21, reduce 1 from the power of x, and I'll end up with 5, add 1 to the power of y, and I'll end up with 2. By the way, 7 plus 0 is 7, 6 plus 1 is 7, 5 plus 2 is 7, plus, I'm going to hit the dot, dot, dot. My last term is going to be an 1, x to the technically 0th, and y to the 7th. Of course, we could term the terms by of an expansion by actually multiplying all the factors, and that seems like a big pain in the tush. Let's try using the combination function for other terms. So remember what the combination function looks like. Over here where I have 4 comma 0, that would be 4 factorial over 4 minus 0 factorial, 0 factorial, which is defined as 1. So I've got 4 factorial over 4 factorial. Well, that's just 1. Here I've got 4 factorial over 4 minus 2 factorial. Okay, so that is 2 factorial. And 2 factorial, that's 2 factorial again. You cannot multiply. So I will end up with 4 times 3 times 2 times 1. Oh, well, the 2 and the 1 take care of one of those. Over 2, I will end up with 6. Over here, I've got a 4 comma 3. That is a 4 factorial over 1 factorial, 3 factorial. That is just equal to 4. And this one and that one are the same thing. It should equal 1. They skipped for no apparent good reason. C of 4 comma 1, but that due to the symmetry should be the same thing as that. So if I list them in order, I've got that 1, 4, 6, 4, 1. Hey, 1, 4, 6, 4, 1 looks a little bit familiar. Okay, what row was that? Row 1 has a 1, row 2 has a 2, row 3 has a 3, row 4 has the 4. So that was my 4th row. That is what I would use to do x plus y to the 4th. Remember how many terms it'll have. It'll have one where x is to the 4th power, 3rd, 2nd, 1st, and 0th. So it'll have 5 terms, 1, 2, 3, 4, 5. All seems to work out. So if I were asked to do this and I didn't want to write out a ginormo Pascal's triangle, and I could, 1, 1, 1, and all that, find the 4th term. All right, well, the 4th term is going to have an a in it. It's going to have a b in it. The first term will have a to the 12th. That's really what I'm going to call the first term, 12. And then the next one is going to be, getting on the camera here, it's all backwards. So I'm going to have a 12, 11, 10, and 9. So I'm really subtracting 4 and adding 1. So a to the 9th and b to the 3rd. I didn't have to do anything real quick. I didn't have to go 0, 1, 2, 3 or anything, knowing that these two numbers will always add up to be that 12. All right, what number goes in front? Well, that is that C of 12, comma, and let's remember that first term is the 0th, so it really is that 3rd one, that's same as this or the same as that. Remember, C12, comma 9 is the same thing as C12, comma 3. And that to me looks like a perfectly good answer. We could work it out. Oh, I hope I've been showing that the whole time. Yikes. We could work it out, but we know where it gets. Okay. Here it is all summed up for you. For any positive integer, the expansion of a plus b to the nth is given by, and they have a dot, dot, dot in the middle, so don't get lost. We start with n, whatever power we're taking it to, 0. We end with n comma n. Those two things will be the same. These two things will be the same. It is symmetric like that. It gets a little confusing in things like example 3, and to the 4th power, you know, that's not a whole lot. I'm just going to go ahead and do some Pascal's triangle. 1, 2, 1, 1, 3, 3, 1. That's not enough, even though there are 4 terms. 1, 4, 6, 4, 1. All right. What's confusing is that I'm going to have a 1, and that's not really my coefficient, because what am I multiplying by 1 by? 3x to the 4th, and technically a negative 2y to the 0th, plus 4 times 3x to the 3rd, and a negative 2y to the 1st. Plus 6, 3x to the 2nd, and dot, dot, dot. We are going to have to figure out what these things are. 3 to the 4th is 81. Negative 2 to the 0th is just 1. So really, I'm left with an 81 x to the 4th as my first term. Plus, well, this is going to be dividing by 3 because I have 3 less, but also multiplied by negative 2. So divide by 3, I get 27. Multiplied by 2, I get 54. And then I have to multiply in this 4, which was different. So 54 times 4 should be 216. So 216, almost forgot my negative sign, x cubed y to the 1st plus, well, I have a 6, 3 is being squared, so I'm at 54, and a negative 2 is being squared. So I had 54 times 4. I think we're at that same thing, that 216. 216. Sorry, lost track there. I got an email in the midst of my thinking there. X squared, y squared. Notice those two things add up to 4. Those two things add up to 4. That and 0 add up to 4. Let me double check on my work there. So I had 6. Yeah, that sounds good. Instead of multiplying by 4, I'll multiply by 6, which gives me 1 less 2 and 1 more 3. But I lose 1 3 and I gain 1 2. It all makes sense. All right. Plus dot dot dot. Okay. I believe that is going to do it for today. Thank you for watching. Have a good one, everyone. A good long weekend, I should say. How do I turn this thing off? Stop recording. How about that? Okay.